In this problem, we have two plates on top of two wheels. The top plate is going to the left at 6 feet per second, and the bottom plate is going to the right at 10 feet per second. We want to know what the velocity of the center of the wheels are. We'll use relative motion to solve this problem. Using relative motion and the relative motion equation, we know that the velocity of the center of the wheel, Vc, is equal to the velocity of the top of the wheel, Vt, plus the velocity of the center with respect to the top. Now the velocity of the top of the wheel is just the velocity of the top plate. So substituting in what we know, the velocity of the top of the plate is 6 to the left, which is a minus 6 in the I direction. And this portion of the equation is our rotation, so we write that as the angular velocity of the wheel crossed with the radius from the top to the center, or the radius to the center from the perspective of the top. This cross product can be solved by setting up our matrix. In this case, our rotation, we don't know what that is, so we just call that omega c symbolically. Our radius from t to c, or c from the perspective of t, is 0 in the x direction, or the I direction. And since our distance from the top of the plate to the bottom plate is 1 meter, then our radius is half a meter, so our distance from the top plate to the center is half a meter, and it's downward, so it's negative. So we'll put that in as negative 0.5 and 0. Now if we do our cross product, the I component is 0 minus a negative 5 times omega c. J component will be 0. K component will be 0. So this is simply equal to omega c times 0.5. Substituting that back into our velocity equation, minus 6 in the I direction. This was also in the I direction, plus 0.5 omega c in the I direction. So we can't find the velocity of c without omega, and we can't go any further with this. So we need to look at it from another perspective. Well, let's find, we know the velocity of the top and we know the velocity of the bottom, so let's find some kind of relationship between those two. So the velocity of the top is equal to the velocity of the bottom plus the velocity of the top from the perspective of the bottom. Again, this is a rotational component, so this is equal to velocity of the bottom plus omega c crossed with the radius from the top, the radius to the top from the perspective of the bottom. Doing that cross product, omega c cross r tb I minus j k 0, 0 omega c, and x component of the radius is 0. The radius to the top from the bottom is positive 1 and 0. J component is going to be 0. K component is going to be 0. The only component we have is the I component, which is 0 minus omega c times 1, which will give us negative omega c. However, we know what the velocity at the top is. That's minus 6 in the I direction. We know the velocity of the bottom. That's a positive 10 in the I direction. And our cross product is also in the I direction for the relative motion portion, minus omega c in the I direction. Since these are all in the I direction, we'll just write this as minus 6 is equal to 10 minus omega c, and omega c then is equal to 16 radians per second. So there's our intermediate answer. Now we can take this and plug it back into this equation to find what the velocity of the center is. So the velocity of the center is equal to minus 6 plus 0.5 times 16, all in the I direction, which is equal to a minus 6 plus 8, which equals 2 meters per second to the right.